Hey kiddos, here's the review for Spiral 20, and we're going to start off with radical equations and graphs. The first thing that we're going to look at is number 2, and here we've been told that we're going to sketch a graph of g is equal to 2 times the square root of negative x and then minus 5. There are a couple things going on here. First is I've got a horizontal flip. That means that my graph is going to be going this way instead of the way it's currently going. Second thing is that we're going to be going down 5, and I'm going to get that point from the vertex. And we're going to have a first point that's going to be up 2 over 1. So this is kind of like the stretch part. And then putting all these three things together, I'm going to start from that first point. I'm going to go down 5. That point will not have any stretching going on. It's just going to be that point as is. And then I like using this idea of a stretch to graph the next point, and I'm going to be going up 2, and because we're flipping, I'm going to go back 1 instead of forward 1. That means my graph is going to look like this. For the domain, it's going to be x is less than or equal to 0, because we're starting at 0 and going backwards. And for the range, we're starting at negative 5 and going up. So we're looking at y is greater than or equal to negative 5. I didn't mark which one of these I'm going to do. I'll just do this first one. Why not? We are solving this equation, checking for extraneous solutions. And I'm going to try to get this radical by itself before I do anything else. Get a minus 2 to both sides. And then divide everything by 3. That's going to be 3x minus 6 is equal to 3 times the square root of x minus 6. You can divide both sides by 3. That gives me x minus 2 is equal to the square root of x minus 6. I do have to square both sides. On the left side, that gives me x minus 2 times x minus 2, which when I do some double distribution, gives me x squared minus 4x plus 4. And on the right side, I'm going to have x minus 6. Bring that to the other side. I'm going to end up with x squared minus 5x and plus 10. And that's not going to be factorable. In fact, if you then try to use the quadratic formula to solve this, you're going to end up with only imaginary solutions. So this would end up being no solution. The graph for this, if you were to graph each piece of this, the line would look like this, the parabola part would look like this, then they're never going to hit, which is kind of weird. For the other one, I'd be doing minus 2 to both sides, and that gets me 189, then dividing that by 7. 189 divided by 7 is going to be 27. So we have the cube root of x minus 5 is equal to 27. Then I'm going to cube both sides because that seems like a pleasant number that we're going to end up with here. So if I cube that, I don't know why this is giving me a problem. So 27 to the third power is 19,683. 19,683 is equal to x minus 5. Sorry, I forgot the cube root there. Which means that x is equal to 19,688. Next up, we've got rational exponents. We got to do some conversions at first. I'm going to do number 5. I know that I need to start off by getting my base here. That's going to be x plus 2. That's the radicand, the thing inside the radical. My exponent is going to be the numerator, and my index is going to be the denominator. You need those parentheses. At this point, the problem is done. Similarly, for number 7, here we're going to have inside the radicand 4 minus c, that's the base. My denominator is going to be the index, and my numerator is going to be the power. I probably will put that on the outside just to make that a little bit easier to see that it's not on just the c. For number 9, we got to reduce this radical, and to do that we're going to do some factoring. 242 is going to end up being 121 times 2, and that happens to be 11. We then have x to the third, and I can write that as x squared times the square root of x. And the square root of x squared is going to be x if we assume that the things are positive. And by things I mean variables. So we get 11x on the outside, the square root of 2x on the inside. Although, to be honest, if you leave it like this, you are done. Lots of video things down here. Here we have an exponent rules thing. We just got a power to a power. We know we got to multiply those. That's going to be 1 times 5 is 5. 3 times 6 is 18. 5/18ths. At this point, you're done because that's a variable. It's a little bit different for number 11, where we have some things that we might be able to reduce. I'm going to write this as a radical, just to make this a little bit easier for me to see what's going on here. Although if you type this into your calculator, you will get the right answer, and I would be okay with that, to be honest. But here we've got the square root for the 2 on the bottom of 4 over 9, and then whatever we get to the third power. That's the same thing as saying the square root of 4 over the square root of 9, and then to the third power. Square root of 4 is 2, square root of 9 is 3. To the third power, we get 8 over 27. For number 12, we're going to get the rational expression thing by itself, sorry, rational exponent expression, which means I'm going to divide both sides by 2. When we do that, we get x to the 4 over 3 is equal to 16. I'm going to rewrite this as a radical. The cube root of x to the 4th power is equal to 16. I've got to take the 4th root of both sides to get rid of that 4th power, and I get the cube root of x is equal to 2. When I cube both sides, I get x is equal to 8. And that's it for this page. Next up, we got some exponential and log stuff. I'm going to sketch a graph based on the log thing. And here we're going to go 3 to the right and 1 up based on my transformations here. That includes the asymptote, so I'm going to move that first. It's going to go 3 to the right and find itself at a value of 3. I'm going to take my 2 points. 1, 0 is going to go 3 to the right and 1 up. 4, 1 is going to go 3 to the right and 1 up. And my new log graph is going to look something like this. For the exponential part, here I did not give you a mother function to use. I'd like you to know that that last number is the horizontal asymptote. And from here, it may be easiest for us to build a table with a couple points. So if I plug in 0 for x, 2 to the 0 is 1, 3 times 1 is going to be 3, minus 1 is 2. So we get 0, 2. And if I plug in, let's say 1, this is going to get real big real fast. We're going to have 6 minus 1 is 5. And I have a feeling that if I try to plug anything else in, I'm going to go way off the grid here. Or get some unpleasant decimals. So that graph would be something like this. Not great at fitting on here, but if you have the asymptote in a couple points, you're in good shape. For number 16, the big idea is that logs and exponentials are inverses. That means that these points are all going to be switched. So if these are on the graph of 2 to the x, the graph of log base 2 of x would end up being 1, 0. 4, 2, and 16, 4. Just switching those points around. For number 17, we're doing some conversions. This is based on the idea that if you've got log base b of some argument that's going to be equal to an exponent. That means the same thing as the base to an exponent is that argument, or my log b is named bia. So here we've got 2 to the 5 is equal to x for the first one. That would be the end of that problem. For the second one, we're going to have log, my base is 3, of 1 is equal to 7x, and at that point you were done with that one as well. No need to take those any further. Evaluating these logarithms, we have a trick where we write these equal to an exponent. 2 to some exponent is equal to 1. That exponent has to be 0. Anything to the 0 power is equal to 1. And then for the last one on this page, 2 to some exponent is equal to 1 over 16. I know that 2 to the 4 is equal to 16. 2 to the negative 4 would let me flip that. So we've got 2 to the negative 4 is 1 over 16. And then last, we got the new stuff. This is the algebra side of exponentials and logs. Here we got some log properties. We've got 3 of them to work with. The first is that if I have 2 logs being added together of the same base, that's important, but it's not going to be tested here. That means the same thing as multiplying them on the inside. That's because logs are exponents, and the exponent rule multiplying bases gives you the sum of the exponents. That's what's going on here. The answer to the first one would be log 2 times x, and you'd be done. The second one's combining 2 different rules. The first rule that we got to deal with is if I have numbers being multiplied out front. We talked about this as log of a to the b power is the same thing as b times log of a. The big idea there was that this is a power to a power. So the first thing I might do would be to write this as log base 2 of x cubed minus log base 2 of w squared. And then the last piece here is I'm subtracting. That means I'm going to be dividing. The big idea there was log a minus log b could be written as log of a over b. So here we're going to have log base 2. That 2 just stays the same, just sits there. And x cubed divided by w squared. For the last one, I'm going to show you how we can do everything at once. Here we've got subtraction, we've got addition, we've got power to a power. And the way that I set this up is I write one big log, nice big parentheses for that. I'm going to put a fraction bar in there. And if I have positive things, they're going to go up top. I know that this would become the power. So that would be x squared. This would become the power on the y. This would be times y to the third. And then this would become the power on the w. Since we're subtracting, it's going to go on the bottom. W to the fourth. Sometimes you can do these all in one step, and at that point you'd be done with this problem. You could also do that in a couple separate steps, doing the powers first and then doing the combination the other ways, and that would be okay too. For number 20, the first thing, if I'm dividing, that's going to turn into subtraction. So that would be log base 2 of x minus log base 2 of 6. And at that point, you would be done. And for the last one, I'm going to do this in pieces. The first thing I'm going to do is to write this as log base 11 of 2x to the fourth minus log base 11 of zw squared. The last part's actually going to be the tricky part here, so we'll come to that in a second. Here I'm still got 2 things being multiplied together, and that would be log base 11 of 2 plus the power was going to come down front, 4 log base 11 of x. For the other ones, because I've got 2 things being multiplied, it means I'm going to add these things together, but I've got to be careful. I'm going to put these in parentheses. So the 2 things being multiplied together here are going to be log base 11 of z, and then plus log, it's going to be 2, I'm going to bring that power down front, log base 11 of w. And at this point, you can stop. You could also distribute that negative and get minus for both of those things. That would be okay. Okay, 21. These are some of the weirder things that we've done recently. What I'm going to do is to write these all as a power of 2. That's the smallest number I see here. And by the way, this should be a power of x. Something happened there. So this would become 2 to the 2x plus 5. 32 is 2 to the 5th. And 4 would be 2 squared. And that would also be to the x power. Again, that's supposed to be a power. I know that if I'm multiplying two things that have the same base, I'm going to add those exponents. That would give me 2 to the 5 plus 2x. And now I see these things have the same power. For the next one, this one's a little bit harder than the one we just did. The first thing I might do is to try to make some sense of what's going on here. I'm going to write everything as a power of 3. So the left side remains unchanged, 3 to the x squared minus 4. The right side is going to be 3 squared times 3 to the x, all to the x minus 2. I'm going to do the parentheses first just because that seems natural to me, but doesn't really matter if you want to distribute that. So you've still got x squared minus 4 on the left. And here we've got 3 to the 2 plus x, and that's raised to the x minus 2. Now I know I need to multiply those two powers together. I'm going to do that over here. And when I do that, we get 2x, we get minus 4 plus x squared and a minus 2x. My 2x's cancel out, and I'm just going to rewrite the stuff on the left. On the right side, that's going to give us 3 and then negative 4 plus x squared, which happens to be the same thing as x squared minus 4. Another way that you might do this would be the one below here. And here we've got 3 to the x squared minus 4. On the right side, that would be 3 to the x squared. 81 is the same as 3 to the 4. And if we're dividing, we can subtract those exponents. That's going to be 3 to the x squared minus 4. All right, for number 22, we're looking at solving these equations. I've got to get the exponential thing by itself, so it's going to be minus 7 to both sides. We get 3 to the 3 times 2 to the x is equal to 9, dividing by 3. We get 2 to the x is equal to 3. I'm going to convert that into log form. Log base 2 of 3 is equal to x, and at that point we're done. For the next one, we're going to divide both sides by 4. We get log base 3 of x minus 3 is equal to 4. I'm going to convert that to exponential form. So that's going to be base to the exponent. 3 to the 4th is equal to the inside, x minus 3. 3 to the 4th is 81. So 81 is equal to x minus 3. I'm going to add 3 to both sides. We get 84 is equal to x. And the last one, again, I'm going to get the exponential thing by itself. I'm going to minus 15 to both sides. We get 5 times 11 to the x plus, a little bit ahead of myself there, x plus 2. And that's going to be equal to 10. I'm going to divide both sides by 5 to get 11 to the x plus 2 is equal to 2. I'm going to convert this to log, and that's going to be log base 11 of 2 is equal to x plus 2. And then finally I've got to get that x by itself, and here it actually gets a little bit easier because we cannot combine those things. So we get log base 11 of 2, and then minus 2 is equal to x. At this point you're done. You cannot do anything else in this problem.